welcome to this presentation. My name is Tailoka Frank Person. I will take you in D2 Quantitative Analysis and CA 1.2 Business Statistics, Answering Techniques. What you are supposed to know in the first place is that in D2 Quantitative Analysis, the learning outcomes are that on successive completion of D2, you should be able to 1. Demonstrate the use of probability where risk and uncertainty exist. 2. Apply financial mathematical techniques. 3. Apply techniques for presentation and analysis of statistical data. 4. Apply business modeling techniques to analyze data. In CA 1.2, Business Statistics, on completion of this model, candidates will reach a competence sufficient to be able to 1. Understand the business and organization need for data analysis. 2. Summarize and categorize business and data organization. 3. Apply statistical techniques accurately. In DA2 quantitative analysis, the most common mistakes you students exhibit are 1, which I'll take you through in terms of the practical examination questions and answering techniques. The common mistakes are wrong formulas, wrong summations, and wrong use of the Z-score in terms of using the probability tables. I'll take you through some examples which are typical of the examination questions. For instance, if you look at CA 1.2, which is Business Statistics, and D2, which is Quantitative Analysis, use of long formulas on a question to do with regression analysis. Let us look at example 1. The following data, for instance, show the number of pairs produced and the cost of production in thousands of quarters during several weeks at a shoe factory. Roman numeral 1, you'll be asked, for instance, to plot the data and estimate the population regression. In 2, you'll be required to find the coefficient of correlation. Mostly question 3, they will ask you to find the coefficient of determination. How do you handle a question like this? In part 4, they even ask you, because the most important thing about regression analysis is to try and forecast that is in the future. And this is the data you are going to have. We are given, for instance, the weekly cost, which is a dependent variable. And you are also given the number of pairs, which is X, which is an independent variable. So how do you handle this data? Always, you are going to start with that is the dependent variable, which is X. And you have the dependent variable, which is Y. Now, for instance, we have got your X is 1,860. Its corresponding Y value is 9.6. You have 1,760. The corresponding value is 8.7. You have 1,720. The corresponding value is 8.6. You have 1,640. The corresponding value here is 7.9. You have 1,700. The corresponding value is 8.2. You have 1,900. The corresponding value is 10 in terms of the cost. Lastly, you have got 1,850, and its corresponding value is 9.7. And remember, the first question here is, plot this data. How are you going to plot this data? This is a scatter diagram. You are going to draw, that is, the x-axis will be the independent variable, which is the number of pairs, which is X. This will be our X. And then the dependent variable, which is the weekly cost, will be on Y. Now, what you do is, when you look at your X value, you can see the maximum value, that is 1,900. And the smallest value, if you scan it through, you will see it is 1,640. And if you take the difference there, it will be almost, that is 160. But you ask yourself, how many data points do you have, so that you come up with a correct, that is, scale. You have got 1, 2, 3, 4, 5, 6, 7 points. Here you have got 1, 2, 3, 4, 5, 6, 7. That is on the y-axis. Similarly, on the x-axis, you have got 1, 2, 3, 4, 5, 6, 7. Here, what I've done here is I've got the range. And you know the range is the maximum value minus the minimum point. This range, if you divide by 7, it will assist you to come up with the correct, that is, the scale. Or, and roughly here, if you look at the scale you are going to get here, you have got 160 there. The 160, if you divided that by 7, it will give you 22. Okay? So, roughly, you have got, that is 23. So you can start now with the smallest number, that is for the y-axis here, for the x-axis rather here, which is 1,640. Then you add on this number 23. So the next number, let us say, will be 1,640 plus, that is the 23, which will give you 1,000. The next point will be 1,663. Then again plus 23, which will give you 1,686. Plus again your 23. Until you capture, that is, the maximum number you have there. So you have got the next number here will be 1709. Plus the 23, which will give you again 1732, plus again the 23, which will give you 177, sorry, that is 1755. Okay, then plus another 23, which will take you to let us say 778. This will be a 1778 plus another 23, which will give you 1801 plus another 23. This is like you are getting the scale so that you fit in the x-axis. So we have here, that is the x-axis, then here we have our y-axis. So in this scale, if you remember the numbers we can start with the smallest number, which is 164. Here we have got, that is 164. For the scale to capture, so that you even capture the maximum number, the 23 which we have there is just a what? A minimum number. So you can even take the 40, you can take the 25, and the scale will differ from individual to individual. So if you take, for instance, 1,640 plus the 40, the next number there will be 8 plus 40 there. The next number will be 720. The next number here will be plus, that is 40, which will be 1760 plus 40, which will be 180. Then here we have got 1840. Then we have got 80. If you add the 40 here, you have 19, that's a 20 there. Then for the y-axis, if you look at the numbers, we add, that is 9.6, 8.7, 8.6. So the smallest number there is 8.2, and the maximum is 10. So again there, if you divide 10 minus, that is 8.6, that will give us 10 minus 8.2, which will give us 1.8. You divide that by, let us say, by 7, it will give you 0.257. The nearest one number you get, that is 0.3. Okay, you get 0.3. So that means here you are going to start at the smallest number, which is 8.2, but the scale here to be 8. Let us say 5, 8.8. Then here you're going to have plus 3 there, 1.9. To get that scale, all what I'm just doing is 8.2 plus 0.3. The next number will be 8.5 plus 0.3. That is your scale. Now, all what you do now is you can now plot that is a scattered diagram. So, if you go now to the original data, which we have here, you are looking at 18.60, okay? And you ask yourself, where does it fall? You see 18.60, that maps into 9.6. So 18, we are looking at 18.0. You come here. In between here, 1840 and 1880, you have got 1860. Okay? That is your x. The corresponding value of y, if you come to the scale here, you have got, this is 9.4. This will be 9.7. So your 9.6 is somewhere there. That's where the dot is. The next number is 1760. You come here and you find the corresponding value of y, which is 8.7. So 8.7 is somewhere in between there. So a dot there. Go to 1720, it's somewhere here. It corresponds to 8.6. And the 8.6 again is just slightly above here, above 8.5. So that's where you get another dot. 1640 somewhere here, and it corresponds to 7.9, and your 7.9 will be somewhere down here below 8.2. You go to 1700. 1700 is between 1680 and 1720, somewhere there in between there. So you have got a corresponding value, okay, of 8.2, and 8.2 is somewhere there. So for the next one, 1900, the corresponding value is 10. And this is the number which is between 1880 and 1920, and the corresponding value is 10. You check where your 10 is, it's up there. If you add, that is 9.7 plus 0.3, which is the width. So you come there on top there, somewhere there, that's 10.0. And that is where you have that dot. The last one, 1850, is in between somewhere there, and it corresponds to 9.7. Your 9.7 is below, okay, the 10. And this is your scattered diagram. Please, this is your scattered diagram. And this is some of you where you make that is it? Mistakes. Now, let us go into the second question. To draw, that is the regression line, or the line of fit. Here, the only problem again which we have there is in terms of you have identified what your x is, you have identified why your y is. So all what you need to get is x squared, y squared, and xy. Now, you can either do it manually or you can use that is a calculator. You have got your x here, which is 1860. You have got your y there, which is 9.6. you have got your 1760, 8.7, 1720, you have got your 8.6. We have 164 again, that is a 164 maps to 7.9. We have 1700, which maps into, that is 8.2. 10, we have got, that is 900, which maps into, that is 10. We have got the 850, which maps into 9.7. Now, what you do is get the summation of x, get the summation of y. What you need is, you need to fit in the line y equal to a plus, that is bx. Your a, you get the a second, the first value you get is b, because b will be equal to summation of x, y, minus summation of x, summation of y, over n. This is over summation of x squared minus sum of x all squared over, that is n. When you get the value of b first, then you go to the value of a, because the value of a will be equal to a y bar minus bx, b times x bar. And all our students, you ask, what is y bar? Y bar is the mean of y, summation of y over n, minus b summation of x over, that is n. This you do it if you want to do the question that is manually. You can use, that is, a calculator to get, that is, all the values without any problem. But if you are using a calculator, then you know. You start with the x, the pair, because you have got a pair, that is 1,860, comma, that is 9.6. So if you go to your calculator, for those who are able to use, that is, a Casio calculator, you just go to mode, okay? Use mode. If you place the mode there on your calculator, it will show you one comp, which is 1. Then it will show you standard mode, which is 2. It will show you regression, which is 3. 3 is the regression analysis, which question you have been given. Okay? Now, if you place only 3, it will take you to line. It is written as line. It's linear regression. The one number is 1. Then you place the 1 on your calculator. Okay? Then what it is telling you, you can enter the data in regression. Like the number you have 1860, comma, the comma is there where there is m plus. The comma, this comma is where there is this symbol next to the symbol m plus. That is where there is a comma. You place a comma and then 9.6. Then place store, okay? The same m plus there, that is the store. It gives you n equal to 1. That means one data point has gone in, okay? Then you go to 1,760, comma 8.7. Then m plus, it will give you n equal to 2. The second observation has gone in. Okay? It will give you for the first observation n equal to 1. Then if you go to 1760, comma, that is 8.7. Then if you place m plus, it will give you n equal to 2. The second observation has gone in. So you can follow that. You go again to 1720, comma, that is 8.6, and place m plus, that is 1720, comma 8.6. Then m plus, n equal to 3. Then you go to 1640, comma, that is 7.9. M plus, n equal to 4. Then you go to 7100, comma 8.2, m plus n equal to 5. Then 1900, comma 10 m plus 6. Then 1850, comma 9.7 m plus. And it will give you n equal to 7, meaning that you have entered all the 7 observations. The calculator will do all the work for you. Okay? The calculator will calculate the value of A. The calculator will calculate the value for B. So if you go now to shift, then there is a sum shift. You place where it is written shift. Then you go to S var. This will give you the summation of x. Shift S var, it will give you sum of x. If you place 2, summation of x, it has calculated for you, which is 12,430. It will give you summation of x squared. Shift S var, follow the cursor key. 1, it will give you 22,127,700. It gives you all the values, summation of y. Shift S var, then follow the cursor key. 1 equal sign. It will give you 565.55. The summation of y squared. Shift S var, follow the cursor key. Number 1, it will give, shift S var 2, it will give you 62.27. That is, if you check this is sum of y squared, this is summation of y. Then the cross product, summation of xy. Again, you go to the calculator, shift S var, follow the cursor key to give you number 3, and it will give you 111,801. Again, use, that is, shift S var. Shift S var. Then follow the cursor key up to the end to give you A, B, R. So A, number 1, that is the value of A. And your A will be equal to minus 5.86 to 2 decimal places. B, shift S var, follow the cursor key, B, and it will give you, that is 10 to the power minus, that is 3, which is the same as 0.00 but 8 what? 83. That's the value of B. Again, please check. If you see the first one is S sum, not S var. The second one is S var. So here, please, if you check here, this is S sum. This is S sum on the calculator. It will give you those values. So the required answer in B, the regression line y hat, will be equal to the value of A minus 5.86 plus the value of B 0.0083. Okay? If you remember, the next question there was calculate the coefficient of correlation. What's the coefficient of correlation? The coefficient of correlation is the strength of the relationship, and at the same time it gives us the direction of the relationship. The coefficient of correlation gives one, strength of the relationship. Two, it gives direction of the relationship. In our case, again, if you are using that is a calculator, you just go to Shift S var. Using a calculator, just go to Shift S var and follow the cursor key up to the end, number 3, and equal sign. It will give you the value of R will be equal to 0.99. And in most cases, you find that those who are doing that is CA 1.2, the answer ends here. But for those who are doing DA 2, they will even ask you, comment on the value of R. The value of R is 0.99. Your R, if it is greater than, your R is always greater than or equal to -1, but less than or equal to 1. Now, what happens is this. You have got 0 here, you have got 1 here, here you have got -1. Any value in this range here to the left, this will be a strong but negative relationship. Here it will be weak but negative relationship. Here, if you have got this is -0.5, this is 0.5, the positive value. In this region, you are going to have a weak but what? Positive relationship. Here you are going to have a strong but positive relationship. Any value close to 1 will be positive. Okay? Any value close to 1 will be a strong positive relationship. But any value close to -1 will be strong but negative relationship. So our value here, what we have got, the value is a positive 1.99. That means there is a strong positive relationship between X and Y. In our case, we are talking about cost and what? And production. There is a strong relationship between cost and production. Then the next question which we are asked is to compute the coefficient of determination. Coefficient of determination is the square of the coefficient of correlation. So R squared will be equal to 0.99. You square this value, and this value, if you square it, it will give you 0.98, or this is what? 98%. This is the coefficient of determination. The coefficient of determination is just telling us about how much of the information can be explained by the fitted line. How much of the information is being explained by the fitted line. Okay? How much of the information? So 98% of the information is being explained by the fitted line. And what it means that the line which you have come up with can be used to predict, that is the cost of what? The cost of production. The last question there, if you see, now they're asking you to use the line which you have come up with, the regression line, to make now the prediction. Okay? To make the prediction. Our line is here, which is here. Okay? So you are being asked to use it for prediction. Y hat being equal to minus 5.86 plus 0.0083. Okay? We are being told that our x, if you remember, we are given our x 1,700. What will be? Predict the cost when 1,700 pairs of shoes are produced. So in this case, our x is 1,700. So where there is x in your fitted line, put that value. Or if you want, you can use that is the calculator to get the predicted value. So your y hat will be equal to minus 5.86 plus 0.0083, and you have got a 1,700 comes there. And if you multiply that 1,700 times 0.0083, that will give us 14. You have got your y hat being equal to minus 5.86 plus 14, let us say 0.11. And this will be equal to minus 5.86. And this will be equal to 8.225. So in my case, my emphasis is on the use that is of a calculator, instead of using that is multiplying where you make what? Where you make mistakes, and the formula is there for you. The next question, if you look at the mistakes which we make, is in terms of understanding, where we have to use that is statistical tables. In B, we have got this question. A company has recently raised the price of its sales and simultaneously instituted a large advertising campaign. In the past, the company had about 70 customers per day. And we are told, let X denote increase in customers per day after the price increase and advertising campaign. You are told that X is approximately normally distributed with mean mu and standard deviation sigma equal to 5. Again, if you look at this question, this is a standard normal distribution question. And you are given the short form. N stands for normally distributed. The 10 there stands for the mean, mu, and the 25 there, if you are given that short form, stands for the variance. So how do you work out a problem of this nature? In this question, we are saying you are given the normal distribution, mean is 10, then we are given variance 20. In which case they are saying our mean is 10, which is mu, and the standard deviation is the square root of 25, which is just 5. In the first Roman numeral 1, you are being asked to find the probability of X greater than or equal to 12, less than or equal to 16. Now, find this probability. In most cases, guys, we are using the z-score, X minus mu over the standard deviation. This is the z-score, what you call z-score. This is what we are using. So you standardize. The X here is this value which you have been using. So for instance, the z-score, when X is 12, then you have got Z equal to 12 minus mean you are given that is 10 over the standard deviation, which is what? Which is 5. So this will give us 2 over what? Over 5. And if you divide this, it will give you point what? 0.4. Then you go to when x is 16. Your z score will be equal to 16 minus 10 over 5. And if you simplify this, this will be 6 over that is 5. And 5 into 6, this will give us what? 1 point. Okay. It will give us the 1.2. Okay. Now, what you are being asked here is to find now the probability of z greater than or equal to point that is 0.4, and you have got less than or equal to 1.2. Now, in your course, you guys, you have got a z table which is a 0.5. If you look at this, you are looking for this area 0.4 here and 1.5 here. And this is the area you are looking for, the shaded area here. This is where you people make mistakes. Now, the table which you have, it gives you 0.5. They are all positive. The area to the right. It is symmetrical about 0. So it will give you the area from 0 to 1.2. Okay? It will give you the area from 1.2. If you go to the tables and check, okay? If you check the tables, even in your manuals, that is, you have got, that is business statistic manual, which was printed in 2017. And also you have got for decision making analysis, there's another manual which was printed in 2017. If you are using that manual, you can just check. These are given very clearly in your table. So you are reading, if you are checking, okay, the largest 1.2. That means if you check the Z tables, down here you are going to look for 1.2. Across here on the Z table, okay, you are going to look on the first point, this will be 0.00. The next one will be 0.01. But go to this number here, 1.2, because 1.2, you are given along the column here to 1 decimal places. The 2 decimal places are across the row. Across there, that's where. So plus 0.00, it's like you add this. And this will be 1.2, which you have. So where the 2 intersect, you find where the 2 intersect for the larger one, and you find it is this value will be 0.3849. Okay? The larger one, which is from here to there, 0.3849. Now, if you check again in the same tables, you check down here, you find 0.4. But across here, it's 0.00. Where these two intersect these numbers, you get the number 0.155, that is 4, when you are using the tables. So it means now the larger number here, which is 0.3849, should be minus 0.1554. And this will give you, that is 0.2295. That is the correct answer. And see, you can see on the right, all these two numbers are on the same side. Okay? We subtract the larger one from the smaller one. If you go to the next question here, 2. The next question 2 is asking you for the probability of x greater than or equal to, that is 5, but less than or equal to 16. This gives us, that is, you are looking at the z value, the z score for 5,
that is when x equal to 5, the z-score will be 5 minus, that is, the mean is 10 over the standard deviation, which is what? 5. This will give us minus 5, sorry, which will give us minus 1. When x is 16, this will give us, which we have already got there in the area equation, z, which will be equal to 16 minus 10 over that is 5, and this, remember, we got 1.2. So, but when you draw this table, see what we have. You have got minus 1 here and 1.2 on this side. You are looking for this area. You have got a negative and a positive. So if you go to the table here, for minus 1, okay, minus 1 will correspond to the table's 0.341, that is 3, 0. Then for 0 to 1, which we already got 0.38, if you remember, 49. But since we have got opposite sides, and you are looking for this area, you add, please, 0.3413 plus 0.3849, and you get 0.7262. If you go into question, that is 3. Question 3 requires you, okay? Question 3 requires you to find the probability of x greater than or equal to, so 6. If you standardize this, it will give you z score, which will be greater than or equal to, our x is 6 minus 10 over the standard deviation, which is 5. And this will give us probability of z greater than or equal to 6 minus 10, it is minus 4. And you have got your 4, divide that by 5, which gives you minus what? Minus 0.8. So if you go to the tables, see what you have there. You are looking for minus 0.8 greater than, and it is the area to the right. Here you have got 0. This side is 0.5. That other side is also, the area under the curve is 1. You look for this value here, and it will be for the positive side. Okay? And it will give you for the positive side, if you look in the tables, it will be, this will be equal to 0.2881, but plus 0.5. And this is how you get 0.7881 as your answer. If you go into question 4, Roman numeral 4, you are looking for the probability of x less than or equal to 18. If you standardize the value of x less than or equal to, this will be 18 minus 10 over 5, and this will be equal to probability of z, but less than or equal to 18 minus 10 to be 8, again over 5, and you know that will be probability of z. 5 into 8, we know it's to be 1.6. So you have got this area again. If you look at this, you have got to the right, this is to the right, but it's saying less than. It's the area, this area to the left. Here it is 0. It is symmetrical at that point where there is 0. But the tables will give you this value from here to there, 1.6. And if you check, that is for 1.6, okay? For 1.6, if you look in the table, this area from here to there to 0.4456, but the area remaining here is just 0.5. So you add the 2, 0.5 plus 0.4452, and this will give us 0.9452. Part 5 of this question, you are looking for probability of x greater than less than or equal to, that is 8, x greater than or equal to, that is the 3 here. This is the 8. Standardize the 3. You have got 3 minus 10 over 5. The value of x has changed to z, since we are standardizing. This is 8 minus 10 over, that is 5. And this will give us probability of minus, that is 7 over 5, less than or equal to z. Here, this will give us minus 2 over 5. So the value of z, you have your 7, divide that by 5, will give you minus 1.4, less than or equal to, this is z, less than or equal to, you have got again your 0.4, which is your 2, divide, which is minus 0.4. You can see you have got all these values on one side, which is negative, okay, 0. You have got here minus 1.4, and somewhere here you have got 0.4. You are looking for this area. This is the shaded area which you are looking for. So as I said, the larger value here, but here in terms of positive, okay, in terms of positive, you look at 1.4 from the tables, and if you check for 1.4, this value from here to there to 0 will be 0.155, that is 4. And this value from 0.4 to 0, which we have already, that is looked at. So in fact, it's the other way around, okay? You are looking at minus 1.4, I'm saying for the positive sense, which is the larger value, this will give us 0.4192. Then the smallest value, which is 0.1554. So since they are on the same side, you subtract. So you have 0.4192 minus 0.155, that is 4. And this will give us, that is 0.2638. So all what you need to understand here, there are certain instances where the area is on the same side, you subtract. If they are on the opposite two sides, they trap the negative and the positive, please add. Again, the common mistakes which you make is in terms of basic probability rules. The additional rule, multiplication rule, complementary rule, conditional probability, and the independent probability rule. So again, I look at a question which will try at least to illustrate how you are able to use the additional rule. Now, you are given, that is, in this question, you are given probability of A as 1 over 3. You are given probability of B as 2 over 5. You are given the joint probability, that is A intersect B, as being 1 over 6. And you are required to find, that is, probability of A union B. Now, this is the additional rule. For any two events, probability of A union B will just be equal to probability of A plus probability of B minus probability of A intersect B. Unless you are told that A and B are empty or they are mutually exclusive events, they have got nothing in common. Then if A and B are disjointed or are mutually exclusive, then probability of A union B will just be equal to probability of A plus probability of B. So in our case, since we are given, substitute, we have probability of A union B being equal to 1 over 3 plus 2 over 5 minus the intersection 1 over 6. and this will give us, the common denominator here is 30, okay? And you have got, that is 10 plus 6, which is we have got our 10. Here I've got 6 plus, that is 12, minus, that is 5. And this will give us, that is 17 over, that is 30. Others will want to put it in a decimal place. In most cases, either to 3 or 4 decimal places, 6.7. That is 0.5667 is the correct answer. In Roman numeral 2, you are required to find the condition of probability. Given B, what's the probability of A? And the condition, by definition, the condition of probability of A given B will just be probability of A intersect probability of B over probability of B. This is conditional probability by definition. And we are told that probability of B should not be equal to what? 0. So if you substitute what we have there, this will be equal to 1 over 6 divided by 2 over 5, and this will simplify to 5 over what? To 5 over 12, or approximately equal to 0.4167. In part 3, you are asked, are A and B independent events? And again here, you are given the definition, A and B are independent. Are independent if, and it's an if and if only condition. Probability of A given B will just be equal to probability of what? A. Or probability of B given A will just be the probability of what? B. Given the fact that A has occurred, it has got no influence on B, or given B has occurred, it has got no influence on what? On A. The other one which you can use, or others, probability of A intersect B will be independent if and only if the marginal probability or the individual probability, their product, are the same. If the product are the same, you can either use the first one or the second one to tell that the two are independent. So we know the intersection. We are given the intersection, okay? The intersection we are given. Probability of A intersect B equal to 1 over 6, given. Okay? Now, probability of A times probability of B. Again, these are given. Probability of A is given as 1 over 3. Now times probability of B, which is 2 over what? 2 over 5. And this will give us 2 over what? 2 over 15. Okay? Now, the only question is 1 over 6 equal to 2 over 15? And which is what? No. 1 over 6 is not equal to. Therefore, A and B are not independent. That is how you answer the question. In B, given the following probability distribution in the table, determine mean and standard deviation. You have this table given. Your X value is given. We are given, that is X. It's like you are given in this table. We are given X. We are given probability of X. We are given X is 5. Its associated probability is 0.4. We are given 8 its associated probability is 0.2. 6, the associated probability is 0.3. Now the question is find the mean and the standard deviation. The first thing is, this is a probability distribution, simply because 1, the probability of x is greater than, or is less than or equal to 1, but greater than or equal to what? To 0. 2, if you sum up the probability of x, this will give us the number what? 1. So what we have is a probability distribution. What we have is a probability distribution, what you call probability distribution. So that means this has got a mean, mu, which will be equal to summation of x times probability of x. It has got also a standard deviation, and the standard deviation, sigma, will be equal to square root of summation of x squared times probability of x minus the mean, mu squared, which is already here. Okay? This is the standard deviation. The square of this will give us the variance. Okay? Now, so we get 1, mu will be equal to 5 times 0.4 plus 8 times 0.2 plus 6 times 0.3. And if you simplify this, you get 2 plus 1.6 plus 1.8. And this will be equal to, that is 5 point, this we have got, that is 1.8, that is 14, which will give us 4, that's 5.4, okay, to give us 5.4. To get the standard deviation, we get the summation of x squared times probability of x first, and this will be equal to, that is 5 squared times 0.4 plus 8 squared times 0.2 plus, that is 6 squared times 0.3. And this will be equal to your 25 times 4, this will give us 10. We have got 64 times 0.2 plus, that is 2.8 plus, that is 36 times that, which will give us 10.8. And if you add this, this will give us, that is 10 plus 12.8, 12.8 plus 10.8. This gives us 3.6. Therefore, the standard deviation will be equal to square root of 3.6 minus 5.4 squared, and this will be equal to, that is square root of 4.44, which will be equal to 2.11. This will be the standard deviation, and this value inside here is the variance, or sigma squared. The other common mistake, again, which we come across in C1.2 and quantitative method, is exhibited in the next table, okay, where we are told, we are given the frequency distribution. And again, here it's just an issue of computation. We are required to compute the mean, the variance, the standard deviation, the median, and the mode. You are given this table. Class interval 5 to 10, 10 to 15, 15 to 20, and then 20 to 25. We have the frequency here. Short form is just F. We have got 5 here, we have got 6 here, we have got 15 here, and we have got 4. So get X, which is the class midpoint. 5 plus 10 divided that by 2 will give us 5.7. 10 plus 15, which is 25, divided by 2 will give us 12.5. 15 plus 20 divided that by 2, which is 35, will give us 17.5. 20 plus 25, which is 45, divided that by 2, will give us 44.5. So get the product again, X times F, and also get X squared here in this column, and get the cumulative frequency capital F. The product here, if you multiply, this will be 37.5. This will be 75.5. If you multiply, this will be 626.5. If you multiply this, this will be 178.0. If you square X times the frequency, you get 281.25. This will be 937.5. This will be 4,593.75. Then this will be 79.1. Get the sum here of the summation of X times F, which will give us, if you sum up this, we have, that is 37.5 plus 75 plus 262.5 plus 178, and this will give us 553. You sum up summation of X squared F here. If you sum up that number, it will give us 1,573. That is 33.5. So mu here will be equal to summation of X times F over summation of F, which will be 553 over the total frequency here, 19. This is in fact 20 plus, that is 30, and the 30 will come down here, which will be equal to, that is 18.43. You need the cumulative frequency in this table. And how you get the cumulative frequency? See, it's like you are pointing here at this figure here. For the numbers less than or equal to 10, you have got 5. The numbers less than or equal to 15, you have got 6 plus 5, which is 11. Less than or equal to 20, you are adding 15 to 11. So you have 26. You are adding less than or equal to 25, you are adding 4 to 26, which will give us what? 30. That's the cumulative frequency. The next we are getting to is the variance, sigma squared, which will be equal to summation of X squared F minus summation of XF. Again, even these formulas are given to you. Summation of what? F. This is for the population. And then substitute the values which you have. It's the issue of adding the correct what? The correct values. So we have, that is 13,733.5 minus sum there 553 all squared over, that is 30, over down over 30. And if you simplify this, it will give you, that is the variance, which is 117.996. This will be the variance. Roman numeral 3, the median. We are required to find the median. Since we are using, that is grouped data, okay, since we are using grouped data, go to this table here, where I got that is the cumulative frequency. And all what we are saying is, find the position of the median. the position of the median, then we have position of median will just be equal to 0.5 times n. Our n there is what? 30. So this will give us what? 15. So we ask ourselves, where does 15 fall? Okay, this number 15 falls where? Where there is what? 26 here. That is where the median lies. So if we are looking at this, this will be the what they call the median class interval. This is the median class interval. So here we look for the lower class boundary plus 0.5n minus capital F here. This is the cumulative frequency below the median class interval over the median class, that is frequency, times the class width. The capital C is the class width. This is the frequency below the median class interval. This is the frequency in which the median is. This is the position of the median. And this is the lower class boundary. So if you look at the class boundary, we are saying 15 to what? The class interval is 15 to 20. So the lower class boundaries, the L will be 15 plus you have got the position of the median is 15 minus the cumulative frequency below the median class interval, it is 11, times the class width, which is 20 minus 15, which gives us 5, over the frequency in the median class interval, which is what? Which is 15. So if you simplify that number, you find that the median will just be equal to 16.333. The mode is the highest frequency. So if you look again at the data which we are given, if you look at that data which we are given, we ask ourselves, where is the mode? We are looking at the mode, which will be equal to the lower class boundary plus b minus a over 2b minus a minus c times the class width. The b is the highest, okay, model class interval. The b is the highest model class interval. The L, this is the lower class boundary. The b, we are saying the highest frequency below, this is the highest model, highest frequency. Okay, this is the highest frequency. The A is the frequency below model class interval. Then the C, that small c, is frequency above the model class interval. This is class interval. This is the frequency of the model class interval. Therefore, our mode will be equal to the highest, again, is the model class interval is 15 to 20. The lower class bound will be 15 plus the B, which is the highest frequency, our B is 15 minus A below, which is 6, over 2 times B, which is 15, minus, that is A, which is 6, minus 4 times the class width, which is 5. If we simplify, we'll get that is 17.2, 17.25. The other common mistake which is made in D2 quantitative analysis is common mistake in terms of lack of understanding again of the concept. And this deals with, that is the binomial distribution. And this is our example 4. In example 4, for instance, we are given, that is the probability that one will make a cell. We are given P, okay, which is probability that one will make a cell. We are given P equal to 0.8. This is the probability that one will make a cell. Assuming 5 contacts are made, determine the probabilities. 1, no cell is made. 2, exactly 1 cell is made. 3, at least 1 cell is made. And 4, at most 2 cells are made. N is given as 5. See, the problem which occurs in this type of question is that, 1, probability of no cell. And if you are able to identify to say this is a binomial distribution, there are only 2 possible outcomes. It's either a success or a failure. In terms of this question, it's either you make a cell or you don't make a cell. Our interest here is making a cell. So the probability of making a cell is P. So the probability distribution is given by probability of X, assuming a value equal to X. You have got this combination formula. X, you are picking any items, X items from the given N. You have got your P to the power X and Q N minus X, where X will run from 0, 1, 2. This goes up to N. So in 1, probability of X equal to 0, where you make no cell. So you are picking no cell from the given 5. And P is the probability of interest. That's where you are raising the number 0. The Q is complement to P. So your Q is just equal to 1 minus P. And this will just be equal to 1 minus 0.8, which will give us point what? 0.2. So you have got 0.2. And you can see this is 0. So the remaining are what? You have made 0 cells. And you are raising P to what? To 0. Then the complement to that will be what? Will be 5. So if you simplify this, just use a calculator. The combination is there on a calculator. If you are using a Casio calculator, you have got the combination formula there. Okay? N, and there is a C and an R there. Or if you have to do it using, then it will be that formula R, where you are picking N, is N factorial over R factorial. Then you have got inside the brackets N minus R. That is the meaning. So the N is 5 factorial. Over your R, you are picking 0 factorial. And here you have 5 minus what? 0 factorial, which is just 5 factorial over 0 factorial and 5 factorial. That will cancel to just give you the number what? 1. And using a calculator, again, 0.2 to the power 5. It is just what? So you have got that is 0.2 to the power that is 5. And it will give you 0.0003, that is 2. You have got 1, 2, 3, 4. The next question was, exactly 1 cell is made. If you look at the issue of exactly 1 cell is made, then you are looking at probability of X equal to 1. And you are picking 1 from the given that is 5. You have got 0.8 to the power that is 1, then 0.2 to the power that is 4. And this will be equal to, you have 5 combination 1, which will give you that is 5 times 0.8 times 0.2 to the power that is 4, and that will give us 0.00, that is 64. At least 1. If you go to the issue of at least 1, probability of X at least 1, this will be equal to 1 minus probability of X equal to what? To 0. And we got 1 minus probability of X equal to 0, which we got as 0. That is 0.2 to the power that is 5. It gave us 0.00032. In 4, at most 2. At most is less than or equal to 2. So you are looking at probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So here we have got probability of x equal to 0, which was 0.00032. Exactly 1, we have got it, which is there, plus 0.0064, plus probability of x equal to 2, which we didn't get. We are picking from 5.8 to the power 2, then 0.2 to the power 3. So we have that combination will give us 10 times 0.2 to the power 2 times 0.2 to the power, that is 3. And that will give us, this value here is 0.0512 plus 0.0064 plus 0.00032, which comes to 0.05792. Okay, that is 0.05792. Again, the other question where there are common mistakes is on the failure to plot the time series. Like if we look at the following data, which shows the gross sales for a mega store in downtown from 2017 to 2019. All what we need is estimate the linear trend, plot the data, and then graph the line, predict also the sales. This is the same as a question on linear regression. But here the common mistake is how you plot the data. Okay? So if you look at the data for this question, you are given time in terms of that is here. We are given time. We are given that is the sales. And the major problem which I can explain here is just how to plot that is the data. We are given time in 2017, where the sales was 4.8. 2018, our sales we got 2.7. 2019, the sales 3.9. 2020, the sales 5.2. Then 2021, the sales 6.5. Now, here the mistake is how you plot the data. We code the time. 2017 we put 1, 2018 we put 2, 2019 we put 3, 2020 we put 4, and 2021 we put 5. So always the time will be X, the sales will be Y. So if you draw your time here, this is Y, this is X. So we are starting with 1, 2, 3, 4, and then 5. Your cells here, again, like what we did in the scattered diagram, always start with the smallest value. In this case, our smallest value is 2.7. How do you make the scale? Look at the largest value here is 6.5. So we are saying 6.5, for instance, minus the smallest value, which is 2.7. And we have got how many data points? 5. Divide that number by 5. So we are saying we can put the width by 0.8. So 2.7 plus 0.8. So the next value there, this will be 3.5. Then this will be 4.3. Then this will be 5.1. Okay. And then this will be, that is 5.9. Then you are going to have plus 0.8, which will give us 6 point what? Let us say 7. Now, you have made sure you have captured the 6.5. Now, you come to 2017, which is 1. It corresponds to 4.8. The 4.8 will be a point, let us say, somewhere here. 2 will correspond to 2.7. 2.7 is down here. Then 3 3 corresponds to 3.9. The point is somewhere, let us say there. 4 corresponds to 5.2. 5.2 is, let us say, somewhere there. Then 5 corresponds to 6.5. 6.5, let us say, somewhere there below 7. Now, you connect these dots. This dot is connected to that dot by a straight line. It's connected to that by a straight line. It's connected to this by that straight line. It's connected to that by a straight line. Because what time series is doing is trying to show the oscillations or the increments in terms of years, how things have been increasing. So you connect them by straight lines. You don't draw a time series graph as a what? As a scattered diagram. No. That's the mistake which you make. The rest of the things in terms of time series, it becomes easy. This is what we have explained in linear regression, which I don't even need to repeat here. But the solutions will be provided to you. Okay, I suggest the solutions. It's just the same as you have got your X, your Y. You have got 1 year, 2, 3, 4, 5. You have got now your cells, again, they follow that 0.8, 2.7, 3.9, 5.2, and 6.5. So then you have got your x squared, your y squared, your xy. Okay? And you fit now the line as y hat, it will be equal to a plus what? Plus bx. And this will be equal to, in the same way, the value of b is the one you start with xy minus summation of x, summation of y, over that is n, and then this is summation of x squared minus sum of x, all squared over n. Our a will be equal to y bar minus b x bar. And your a, if you check, this is the one we get, our a will be, that is, if you simplify, you get 1 as 1.425 plus our b is 0.59x. This is our trend, and this is the trend line. This is what they call the trend line. Okay? Then the next thing which we needed here was just to predict or find for the year 2023. The year 2023, you find that x corresponds to what? To 7 for 2023. Then you are going to substitute your y hat will be equal to 1.425 plus 0.59 times what? Times 7, and this will give you 5.6. This will be your what? This will be your cells in 2023. The other problem which continues in terms of not understanding the concept is on decision-making techniques. And this only concerns, that is, the people who are doing, that is, D2, decision-making. Okay? Like in this, the question A, a woman is considering purchasing stock in one of the following 3 businesses: mining, oil refining, or computer software development. The expected profit in each of those lines as a function of inflation rate is given. Find 1, we can use the Laplace, use Awich, use max, use max-min, use min, max regret. Okay, then find that is the expected monetary value, and also find the expected value of perfect, that is information. This is again a question which you should always get, which doesn't have any complication. How do we do this question? See, the first part where we are saying the Laplace is just the average. Okay? The Laplace is just the average. So for A, for mining, find the Laplace. It's just the average. So you have got 140 plus 510 plus 290. And how many values do you have? You have got 3. So divide that by 3. That will be 940. Divide that by 3, which will give us 300 and what? 31. 313. 33 ngwe. If you go to oil refining, which is A2, the second action, it will be just 420 plus 210 plus 250. Divide that by 3, which is 88 over 3. And that will give you 293.33. Go to L3, the action, the third action, we have got that is 280 plus 300 plus another 300. Divide this by 3. We're just looking for the average. You have got the 600 plus 280, which gives us 880 again. Divide that by 3, which will give us 290 what? 293.33. If you compare the values, you pick the maximum. That means action A1 is the one which should be taken. We take action A, which is the one which should be taken, because it gives you the highest what? The highest payoff. 2, if you are using which alpha, which is given just the level of optimism. How optimistic are you to invest in that? And you always go to the what? To the largest value. If you look at when the state of nature, okay, is high, definitely our alpha here we are given is 0.8. So the largest value there for action A will be 5 what? 510. If you look at action A, it will be 510 times 0.8. The lowest, the worst in that action, which is 0.2, it will be 140. And if you multiply that, simplify, it will just give you what? 436. Action A2, the maximum payoff will be 420 times 0.8 plus the worst of there is 210. Multiply that by 2. That's the worst. 210. If you simplify, you get 336 plus 42. And that will give you 378. On action A3, the best you can do is 300. 4 times 8. The worst is 210.2. And this will be 240 plus 56. And this will give us 296. So again, you go for the maximum. What will be the maximum? A1. So invest in mining, which will give you the highest payoff. If you go to the maximum, this you want to maximize, that is the opportunities. Okay? You have got A1 action when the state of nature is S1. For the max criteria, okay, for the max criteria, we have got this state of nature S1, S2, and then S3. We have got A1, A2, A3 as action. We know A1 is mining. The payoff there was 140, 510, 210. We have A 420, 210, and then 250. Here we have got that is 280, 300, and then another 300. So when you look at max, just write maximum here in that column, so that when you look at action 1, what is the maximum there? It will be 510. Look at the maximum there, it will be the maximum payoff will be 420. Here the maximum payoff is 300. So again, you look at the maximum of the maximum, which will be 510, which is coming with your action what? Action 1. So pick action 1. If you look at the next criteria, okay, which is supposed to be max mean. When you look at max mean, you are looking at, first of all, what will be the maximum there? What will be the maximum there? What will be the maximum there? And then you pick. Again, you have got A1, A2, A3. You have got maximum 510, 420, 300. Now you are picking the minimum from here. The minimum will be what? Will be 300. So you are going to go to what? A2 as your action. If you go to the min max, This is min, max, regret. So then look for what you call an opportunity loss table. Look for the table, or what they call table of regrets. Pick up the table of regrets. So say here, first action, if the state of nature is S1, where are you going to invest? You pick the one with the what? The highest or the maximum payoff. A1, A2, A3. So the maximum payoff would be 420. So there it would be 0. If you had chosen action 1, what would you have lost? You would have lost 420 minus 140. Okay? Which would give us what? 28. If you had chosen action 2, for instance, here, you would have lost nothing. That's why it is 420 minus 420. Had you picked action 3, you would have lost, that is 420 minus 180, which would have been what? 140. S2, action 2. The maximum payoff there is 510. So this will be 0. Then that will be 510 minus 210, which will give you 300. 510 minus 300, that will give you 210. Come to S3. S3, the maximum payoff there, if you see, is 300. So this will be 0. Then 300 minus, that is 250, it will give you 50. 300 minus 290, that will give you just 10. Then pick up the maximum. Pick the maximum from there. That will be 280. That will be 300. That will be 210. These are the maximum payoff. From this maximum payoffs, pick now, maximize the risk. So you minimize the risk now. That's why we talk about minimum now. Pick up the minimum of the maximum because it's like the risk. And these are people who are pessimistic, that is in nature. They will not want to even what? To even gamble. So you pick up what? 210. So action A to be picked will be A what? A3. Then 3, using the expected monetary value. Okay? Expected monetary value. For the first action, here it's where you are given in the state of nature. You know you are given probability of S1 is 0.3. You are given probability of S2 0.3. And you are also given probability of S3, which is 0.4. So expected monetary value of A1 will just be equal to 140 times 0.3 plus 510 times 0.3 plus 290 times 0.4. And if you simplify these values, it will give you 42 plus 153 plus 116, which is 311. Expected monetary value of A2 will be equal to 420 times 0.3 plus 210 times 0.3, then plus 250 times 0.4. If you simplify this again, this will give you, that is 126 plus 63 plus 100, and this will be equal to 289. Expected monetary value of A3, you have 280 times 0.3 plus 300 times 0.3, okay, plus another 300, but this times 4. If you simplify this, it will give us 84 plus 90 plus 120, and this will be equal to 294. Again, here you look at the maximum. The maximum payoff, you see it is 311, which goes with action 1. So we choose action 1. So if you look at the expected opportunity loss, you go to the table of regrets. Okay? So for the table of regrets, which you already have there, expected opportunity loss, you have 280 times 0.3 plus 10 times 0.4. And this will give us 88. Expected opportunity loss A2, you have 300 times 0.3 plus 50 times 0.4, and this will be equal to 110. Expected opportunity loss for A3 action 3, it will be 140 times 0.3 plus 210 times 0.3, and this will give us 42 plus 63, which is just, if you add this, it will be plus 63, which is 105. So expected opportunity loss, action A1 is the best. It gives us the smallest, because that is a table of what? Regrets. The last part of this question, you are looking at the expected value of perfect information. For how much can you sell the information? And always here, you don't even need to do much. The expected opportunity loss is the same as the expected value of perfect information. Okay, A1 in this case will just be equal to 88. Unless you want to use the other formula, it will give you the same what? The same answer. Alternatively, if you wanted, expected value of perfect information, how much you can sell the information for, is expected monetary value minus expected monetary value with certainty. Okay? The expected monetary value, we have already got the value. All what you need is expected monetary value with certainty. Now, if you know the state of nature, to say the state of nature is S1, which action would you take? Okay, you take the one with the maximum, which is 420 times point what? 0.3. Then if the state of nature is 2, you are going to take the one with 510 times 0.3. If the state of nature is S3, the one which gives you the maximum is the one which you are going to take, which is 300 times point what? 0.4. And if you simplify this, you get 126 plus 153 plus 120, which gives us 399. That's what we are going to get. So we have got the expected value, okay? The expected value, we got that is 311 minus the expected value with certainty. And if you subtract it, to give you 88, you get the same what? The same answer. Now, for these two, the problem which we have is just getting the finding now mathematics of finance. If, for instance, the only problem is using wrong formulas. If you are looking for compound interest, the formula for compound interest, please. The formula for compound interest is just PT, you have 1 plus R to the power that is T. Now, in our case, in this question, you are given the investment of 5,000, which is the initial investment, the principal is 5,000. And the interest rate you are given, which is being compounded, that is monthly. So your R will be equal to 0.085. How many times are you compounding? That is 12. And you are given the number of periods you are going to have, which is the T. Our T will be equal to how many times you are compounding times the number, okay, which is times time, in fact, here. Let us say we can put our T here as N. Instead of time here, put this as N, so that the total number of periods will be equal to 12 how many times, and how many years do we have? It is 10 times 10. So that this becomes now 5,000 times 1 plus the interest rate here, which now becomes, if you simplify that, it will be 0.00. The problem with that is the interest rate, especially if you are working with financial institution, is the number of decimal places. Carry as many decimal places as possible. This is to the power that is 120. And this, if you simplify, the answer will become 11,000 kwacha 66, 663 ngwe, 11,663 kwacha 24 ngwe. This is to how much it will grow to in 10 years. Okay? That is our yield. Now, if you look at the compound interest, the compound interest is just to compound interest will just be equal to the total amount, the yield, which is 11,663.24 ngwe, minus the principal, which was invested. And this will just give you 6,663 kwacha 24 ngwe. If you go into the next question asks you to find the present value of an annuity. And the confusion is, what is an annuity? Okay? If you know an annuity, to say it's an amount, an equal amount being paid at equal intervals, then it becomes easy. Okay? This is in 7A. And the present value of an annuity, we use at times A. This is R, this is the annuity itself. And then you know an annuity will be less than the amount of an annuity. So this will be equal to 1 minus 1 plus, that is R to the power minus N. Okay? Minus N. Over down here to be R. This is the formula you use for the present value of an annuity. 1 minus. And this is where the confusion comes in. This is an equal amount coming in at equal intervals. So your R here is 500. Your time is given as t equal to 8. Your interest rate is given as 0.078. But if you read it through, you are saying this amount is being compounded semi-annually. It is coming in after 6 months. So you divide this by what? By 2. And if you divide that by 2, it will be 0.039. And don't forget about the total number of periods. Your N will now become 8 times what? Times 2. And this is 500. You have got 1 minus 1.039 to the power minus, that is 16, over, that is the interest rate, which is 0.0. This is the periodic interest, in this case semi-annually. And if you simplify this, and the answer will now come to 5,869.36 ngwe. Now, the other question in B, it's a question which you need to understand. It is just simple interest. And if you are given simple interest, that is in B, we know interest will be equal to PRT. So you are given the principal, which is 15,000, times you are given the rate, which is 0.15, times the time, which is 6. And if you simplify this, it will give you, that is 1,350 kwacha. If you go to finding the amount, we know the amount is principal plus what? Plus interest. Our principal, how much did we invest in at the beginning? Is 15,000 plus the interest, which is 1,350. If you add this, it will give us 16,300 and what? And 50. It will give you 3,000. That is 16,350. For the future value, if you are asked to find that is the future value, this is what I'm saying. This is an amount of an annuity. Where you make mistake is on the formula. The formula is S equal to, that is R This difference, see the difference between the two formulas. This formula is 1 plus r to the power that is n minus what? Minus 1 over that is r, your interest rate here. So that where the amount coming in, the periodic amount of 200 is coming in, your time is 5, your interest rate is 0.085, and you have got m is the number of periods. Okay, how many times are you compounding your interest? This interest is being compounded what? Quarterly. So that this will be, you are going to divide this by what? By 4. And this will give us 0.0212, that is 5. So if you substitute these values, you have got 200 here, you have got 1.02125 to the power that is the number of periods, which is n, will be equal to 5 times that is 4, and this will be to the power 20 minus 1 over 0.02125. And if you simplify this, you are going to get your 200 here times the discount factor, which will come from this part here, times that discount factor, okay, which will be almost 24.6, and this will be equal to 4,920 or 42 ngwe. The last part where there are complications in terms of where you make mistakes and you fail to come up is the failure to construct a probability distribution when you are given a question on simulation. See, we are given, for instance, the following data, okay? We are given the following data where we have a probability distribution. We are given the sales and we are given the probability distribution here. We have got the sales 500, 600, 1,000, 1,500, and then 2,000. The probability of 500 is 0.06. The probability of 600 is 0.12. That of 1,000 is 0.4. That was 1,500 is 0.15. That is 2.5. And then the last one is 1.7. What we want is to generate the sales for the next 5 days. So the problem here is to just come up with a probability distribution. The next thing you do, come up with a cumulative probability here. Cumulative probability. Come up with a cumulative probability. So less than or equal to 500 will be 0.06. Less than or equal to 600 will be 0.12 plus that number, which will give us 1.8. Less than 1,000 to be plus 0.4, which will give us 5.8. Less than 1,500, you add 0.25 to this number so that you get 8.3. For less than 2,000, you add 0.17, which will give you 1.00. This is the cumulative distribution. Then come up with the, what you call random number intervals in this section. Random number interval in this section. So you are going to have less than or equal to 500. Subtract 1 from this number so that you start at 2-digit number 06 here. Subtract 1 from this number, you start at 17. Here. It can be in points or it can be in what? In all numbers. Subtract 1 here so that you have got what? 57. This will be 82. Subtract 1 here so that you have 99. So here you have got 6 values in this interval. So we started at 0, 0. So then this will be 6, 0. This will be 1, 7. This will be 5, 7 here. This will be 1, 7 here, 0, 7. This will be 1, 8 here. This will be 58 here. And this will be 83. This is the probability distribution table, and this will help you to generate the numbers. Since we are given those numbers, come up with just the five numbers. The first one is 7, 9. The second number will be 9, 4. The third number will be what? 5, 3. The fourth number will be 35. And the last number will be what? 47. These are the numbers which will help you to generate now the demand, and you ask yourself to say, where does this number fall? For instance, if where does 79 fall? You find 79 falls where? 79 falls here. Okay, this is where 79 falls. 79 will fall here. Look at the number 94. 94 will fall here. Look at the number 53. 53 will fall there. Look at the number 35. 35 again will fall there. Look at the number 47. 47 will fall there. So all what you are saying now, for the next 5 days, you are going to generate what? 2,000 cells. 2,000 cells. You are going to generate what? This will correspond to 2,000 cells. And 79 will correspond to 1,500 cells. And then these numbers will correspond to 1,000 cells. Colleagues, unless I've left out any clarifications, but otherwise, this is the material which you have to go through and try to understand to assist you to answer D2, which is quantitative analysis, and those who are doing business statistics, that is CA 1.2. I hope everything is clear and you understand. Wish you good luck in the exams.